Okay, welcome into the exam prep 2, and I'm going to go through the first probably 6 questions here, maybe only 5 actually, because the first 5 take a little bit of time. So first 5 questions, we'll start off with number 1 here. It says translating the graph of a parabola, and we have 2 steps, and the 2 steps means there's going to be a horizontal and a vertical shift. So we have y equals x minus 5 squared minus 1, right? This graph that is given to you is y equals x squared. And now we can do this in either order. Let's just read from right to left. So we have x minus 5 squared, right? This is our horizontal shift. And remember, if we have a minus 5, that means it is going to move us to the right, right? Almost the opposite direction you would think, to the right by 5 units. So this is step 1. The minus 1 is a vertical shift. And so that means we're going to shift down by 1 unit. So vertical shift, kind of intuitive what you would think, up or down, corresponding with the sign. The horizontal shift is opposite, right, of the sign that you have. And we're going to do one more, right? So this is translating a parabola. However, regardless of what graph you have, the steps are pretty much the same, right? We're looking for horizontal and vertical shifts. Let's see if we can find another one. Okay, here is an absolute value one. Again, notice that the graph y equals absolute value of x is given. Anything happening within the absolute value sign, the same way that it was in our previous question, anything that was happening within the squared is a horizontal shift. Now we have a minus 2, so again, it is the opposite direction that you would think. We would move over 2, and we have a vertical shift of plus 5, in which we will move in the same direction as our sign. So hopefully not too bad. Okay, we're going to move on to problem 2. Problem 2 is just in the other direction, meaning before they gave us the equation, we had to create the graph. Now they've given us the graph, and we need to create the equation. Right, so it says the function is defined by f of x is equal to x squared, a nice parabola here, that's f here. Write down the expression for k of x. And so what we're going to do, let's just write down our x squared, right? And we know it has to be some variation of this. And let's look. So first, we have shifted to the left, right, by 1, 2, 3 units. And so within our function, right, the x squared, we have x plus 3. Remember, it's the opposite, right? So I know it's negative 3. So we have x plus 3 squared is our horizontal shift. And now we have shifted up to 1, 2, 3, 4 units, so plus 4. Let's go ahead and do one more. We now have the absolute value sign. So again, same idea, right? Let's just write our absolute value here of x. And let's see. We started at f and we have shifted 1, 2, again 3 units. So the opposite sign, right? X plus 3. This time though we have shifted down 1, 2 units. So minus 2. Okay. So there are our first 2. The next one is going to be on testing for symmetry. So we will do that on our whiteboard here in a second. Okay, so testing for symmetry. We have these 2 different equations. Feel free to write these down. I'm going to work on A first, and we're going to go through the process for both of them. This one will take a little bit longer than 1 and 2. So write down these equations. I will meet you over at the whiteboard. Okay, so for number 3A, I have A written down, and it asks us about symmetry, and we're going to go through the process as a reminder here on how to test for symmetry. So the first one we're going to test is the x-axis. Right? Now the way that you would find symmetry of the x-axis is we're going to take all of our y values and we're going to switch them to negative y's. And our hope is that we get this same equation back out. Right? I know that seems a little strange. So let's see if that's true. Right, so in other words, when I replace my y here with a negative y is equal to 7x minus 1. And now I would like to just have the y on my left side. Right, well, how do I do that? I divide both sides by negative 1, I'll end up with negative 7x plus 1. Now, unfortunately, our goal here was that if we switched these, right, our y's to our negative y's, we were hoping that what we ended with down here, the negative 7x plus 1, was the same as what we started with, right? That would tell us we are symmetric about the x-axis. At the very end, we'll look at a visual, so hopefully that clears it up as well. Now, in this case, these are not the same, right? They're not the same. And so we know they are not symmetric across the x-axis. And again, just a note to yourself here, right? We are switching our y's to our negative y's. That's how we are testing this. And so I want us to think of this same pattern when we go test for across the y-axis. Right, so I'm going to write it down again. Feel free to pause. I know I'm going through this semi-quick here. So this was our equation. We want to now test the y-axis. And so it would make sense before we changed our y's to negative y's for the x-axis, now we're going to change our x's to negative x's. And again, our hope is that if we change our x's, we still end up with what we started with. Now we have 7 times negative x minus 1. Okay, in this case, again, we end up with the issue, unfortunately, right, this is not what we started with, right, it is not what we started with. So not symmetric, we'll just say not symmetric across the y-axis. Unfortunately, right? Now the last one to test is the origin. Right, now for the origin, I'm going to write it here again. The origin, we're doing both, right? We're going to switch the y's to negative y's. We're going to switch the x's to negative x's. And again, we're hoping that we get what we started with. And so let's check. We have negative y is equal to 7 times negative x minus 1. And we get really close, right? So let's just take a couple steps here. So negative 7x minus 1. However, when we divide by that negative 1 on the left side to make it a positive y, we get, well, the positive 7x, this is good, right? However, we get a plus 1. And what we started with here was y equals 7x minus 1. So still, these are not equivalent. So we are not symmetric across the origin either. So unfortunately, this one is none. This is none. And think about the graph that we have here, right? 7x minus 1, that's just a line, and it's just, this is a rough sketch with a steep slope, right? Symmetric would mean there's a mirror image. And we're going to do another one here so that you can see what I'm talking about, but there would be a mirror image either across the y-axis, the origin, or the x-axis. In this case, it's neither. Let's do the second one, because none of the above maybe isn't the best example, right? But it is an answer, so we should know how to do the process. But let's practice this one more time. So for b, we have x squared plus y minus 1 equals 0. And just so we can actually see this, I kind of already know ahead of time. Let's go ahead and test the y-axis first. And remember, the y-axis is where we take all of our x's and switch them to negative x's. So let's go ahead and do that. I switch my x to a negative x. I still have to square it. Plus y minus 1 equals 0, right? Remember, this is my starting, so our hope is that we end with this. Now, if I square a negative times a negative is going to be a positive. So positive x squared plus y minus 1. And the good news is, finally, we have something that is symmetric. So we'll put a check mark. It is symmetric across the y-axis. We started with x squared plus y minus 1 equals 0. And we switched our x's with negative x's. And we ended with the same thing. We'll take a look at this at the end. Let's go ahead and do the rest. Right. So the next one would be the x-axis, and again, just some side notes here. That is where we switch our y's with negative y's. And again, as you do more of these, it becomes more clear, right, which ones are and which ones aren't. Right, if we simplify here, again, this is not what we started with, right? This is a minus y because we switched it to a negative sign, so not across the x-axis. And if you want to take this idea, you can kind of already think about what's going to happen with the origin, right? The origin here is we take our x's, we switch them with negative x's, we take our y's, we switch them with negative y's, right, for the origin. And in this case, we have negative x squared minus y minus 1 equals 0. And again, unfortunately, the x's work out just fine, but that y is still negative, and it is not the same as what we started with, right? We want to, what I have boxed up here and starred now, that's what we want to get back to. So it is only symmetric across the y-axis. And so I'm going to pause this for a second and jump over to Desmos so we can see exactly what I mean by symmetric visually. Okay, so I went over to Desmos here, and I pulled this up, and we can see what I mean by mirror image. Notice this is our y-axis, right down the middle here, where my cursor is moving. And we have a mirror image, or reflection, across the y-axis. The left side over here looks like the right side, right? So you can imagine if we sandwich these together, they would lay on top of each other. Right, that's what I mean by testing for symmetry, right? So in this case, it was just the y-axis. You notice not the x-axis or the origin works out here. Okay, we are on to the next problem. Okay, so this is on to problem 4. Notice it's titled for it. So it says finding the difference quotient for a linear or quadratic function, right? I'm glad we got the linear is the nice one. So let's do the quadratic, right? And it tells you what the difference quotient is here. F of x plus h minus f of x divided by h, where h does not equal 0 for the function below. So take a second to copy this down, and then I'll meet you on the whiteboard and we'll discuss about going through this problem. Okay, so here's our function, and I'm going to write down a reminder. This is the difference quotient, f of x plus h minus f of x all over h. Now the good news is, just to highlight, we already have our f of x. This is given to us, right? And we want to think about this x as a placeholder. Anything I put inside of it, right, instead of the x, is just going to take its place, right? Meaning that if I decide, well, I'm interested, I need f of x plus h, right? That's what's hanging out up here. Instead of x, I'm going to replace all my x's with an x plus h. And of course, I ran out of room, so let's go ahead and move this. And I'll move this, and then we'll also do it all together, and we'll make it a little bit smaller. There we go. I know the arrow didn't work out. That's okay. Minus 3, right? And before we start setting up our difference quotient over here, let's go ahead and do all the algebra ahead of time. It's going to make our life a lot easier moving forward. And so we have negative 2 x squared plus 2xh plus h squared plus 2x plus 2h minus 3. And I know I'm doing this quickly. Please feel free to pause the video at any time. Go through it yourself in case you don't believe me. That's okay. I just want to make sure the video is a reasonable amount of time so I don't make it too long. And of course you can pause the video. Right, so this is the expanded version of f of x plus h. And now I'm going to set up the difference quotient, right? And I'm just going to write it down over and over again until it's stuck in my brain. And so unfortunately, right, this long thing here, let's go ahead. Negative 2x squared minus 4xh minus 2h squared plus 2x plus 2h minus 3. So here's our first part. This whole thing that we just wrote down is the f of x plus h. Now let's subtract out the f of x. And now I want us to be careful here because this f of x is in parentheses. The negative sign being distributed is very important. If we don't write this, we're going to mess up our answer. All divided by h. I know it looks ugly right now, but I promise you it's about to look a lot nicer. Now, if we've done this correctly, what we're going to see is there's going to be a lot of stuff that cancels out. Right, we can see there's a negative 2x squared, and there is a minus, so a plus 2x squared. There is a plus 2x, and there is a minus 2x. There is a minus 3, and there's a minus 3, or a plus 3. And what we should notice is so everything that I've highlighted there will cancel out. And what we should notice is if we've done this correctly, right, this whole thing over here for a quadratic will cancel out. And so we have negative 4xh minus 2h squared plus 2h, and that's it. Another key over h. Another key thing that we've done it correctly is notice that everything in my numerator right now has an h involved. And so what's going to be even nicer is we can factor out that h. And that leaves us with negative 4x minus 2h plus 2 all over h. And another key indicator we are doing our problem correctly is we notice we have some h's that now cancel out. And so our final answer here is negative 4x minus 2h plus 2. Okay, so again, I know I went through that quickly. Please feel free to pause the video, rewatch that. I am going to do one more variation here of the difference quotient for a rational function. The process in setting it up is still the same, but the algebra involved in simplifying is going to be different. But rather than going back and forth, I'm just going to give you another function here, right? So we're going to do the same thing, except for f of x is equal to 1 over x plus 1. And so, again, reminder, I need this, right? I'm setting up the difference quotient. And so I notice I already have my f of x that's given to me. Dividing by h is just putting an h down there, but I do need an f of x plus h. And at least this part seems fairly nice, right? We replace our x with an x plus h, and we still have the plus 1, right? You can think of this as one thing. You don't need the parentheses here, though. So now, there's nothing else for us to do. I know before we did a bunch of algebra before we set up the difference quotient, but right now there's not much we can do, so let's go ahead and set this up. We have f of x plus h, again, just writing it down, minus f of x all over h, and here's our f of x plus h, minus f of x all over h. And this looks really ugly, right? Okay, now for right now, I'm going to highlight. This is all I want us to focus on because this is where all of our algebra issues are going to arrive. Okay, so if we have something, a rational function minus another rational function, in order to simplify that as much as possible, right, they have to have a common denominator. The same way if you added two fractions together, they would have to have a common denominator. And so what I'm going to do is I notice that I have an x plus h over here, but I'm missing an x plus 1. So I'm going to multiply the top and bottom here by an x plus 1. This is my first rational function here. This is this one here. This is just a really fancy way of multiplying by a 1 to create this common denominator. I'm going to do the same thing over here. I notice over here I have the x plus 1, but I don't have the x plus h plus 1. And so by doing this, again, another fancy 1 right here, times x plus 1. By doing this, I've now created a common denominator. And of course, I do have divided by h here. Now I know it looks uglier, but the good news is, now that we have a common denominator, we can squish these two things here into 1. So here's our numerator of our numerator. I know that seems strange to say. There's our denominator of our numerator, all divided by h. Right, so again, I know I'm going quickly. Feel free to pause. I don't expect anyone to be moving at exactly the same pace. We have an x here, we have a minus x, we have a plus 1, we have a minus plus 1, right? So they go, all those will cancel out. So I'll highlight again, right? Positive x minus x, positive 1 minus 1. And so we are now left with h, or negative h, almost messed that up, right? The negative sign gets distributed, all over x plus 1, x plus h plus 1, all over h. And the good news is, these h's will also cancel each other out. And so finally, we're left with -1 over x plus 1, x plus h plus 1 is our final answer. You could think this h here moves up into this denominator, and then they will cancel out with the 1 in the numerator. Okay, please feel free to watch those last two variations of the difference quotient. I know that's probably the one that takes the longest and people get the most stuck on. We're going to do one more problem here, and then that'll conclude this video because we're going a little long on time. So I like to keep these around 12 to 15 minutes, or a little bit over. So let's do only one more problem to get to number 5. Okay, number 5, finding the average rate of change. And this one's a little bit nicer, right? The difference quotient is kind of the extended version. So let's find the average rate of change of f of x is equal to 3x squared minus 5x from x equals 2 to x equals 5. So take a second to write down this function, and I will meet you at the whiteboard. All right, let's go ahead. Now, just a reminder, right? This is all from essentially finding the slope, right? Remember, we started with a line, and we know that the slope here is y2 minus 1 divided by x2 minus x1, and then maybe we want the more abstract version. We can use this for average rate of change, f of x2 minus f of x1, and then finally we went to the difference quotient, but we don't need to write that now. And so let's just write down the information that we have, right? It says between 2 and 5, so I'm going to say, well, that means I want f of 5 minus f of 2, all divided by 5 minus 2. Now the good news is our denominator there, 5 minus 2, we know how to do that. We have to do a little bit of side work though, because I don't know f of 5 off the top of my head, nor do I know f of 2, but we know that we can just plug these numbers in to our original function, and we can get a solution, right? So 5 squared, 25, times 3, 75, minus 5, 70, and f of 2 is going to be 3 times 2 squared minus 5, so we have 2 squared is 4, times 3 is 12, minus 5 is going to be 7. Okay, so now once we have that, let's see where my cursor went here. Once we have that, let's make sure I've done everything right. 4, 12, 12 minus 5, 7. Okay, so we have 70 minus 7. Oh, and I wrote down the problem wrong. That's okay. This should still work out. 70 minus 7 over 3, right? This still gets me a solution. Maybe some of you caught it. I forgot to write down something. We'll probably do it one more time. There was supposed to be a 5x here, but that's okay. Let's pretend that this was the problem. We're still going about it all the same. I just miscopied down. It ends up still being a nice solution. I think 70 minus 7 is 63. Divided by 3, we get 21, right? So not the solution that was to that particular problem, but we do get something nice. Let's do another one since I messed it up. Let me grab another problem. Let's copy this down. We have f of x is equal to negative 2x plus 8. Make sure I write this down correctly, from x equals negative 3 to x equals 1. Okay. So let's jump straight to our setup, right? F of 1 minus f of negative 3 all over 1 minus negative 3. Be careful with the negative signs down there. And now we just need some side work, right? I need to know, well, what is f of 1? F of 1 is going to be negative 2 times 1 plus 8, which gets me positive 6. And f of negative 3 is going to be negative 2 times negative 3 plus 8 gets me 14. And so now filling out our information, we end up with 6 minus 14 is negative 8 over a positive 4 gets me a negative 2. And so let's see if I wrote down everything correctly. I did. Okay, so that takes us to problem 5. Probably either expect today or tomorrow I will post another video taking us from 6 up to probably 12. So I will see you in the next video if I can find the stop button. All right, see you guys.